to the 20th power, and whatever that comes out to. So this sculpture ends up being worth $3,000, approximately $3,000. So it grew a lot, actually. It almost doubled. So after 20 years, the value of the sculpture practically doubled. Cool. This is how things appreciate. This is another way that you could figure out how money appreciates in some kind of savings account. And we've done those kind of problems before. So now obviously when you see 1 minus the rate, this is obviously decay, right? So no matter whatever number you put in for R, it's going to be less than 1, which means it's going to be some decrease, right? Or some decay. Let's see, just like this before, let's do an actual problem. Note that the rate is going to be subtracted. Okay, so the population of a city has decreased by 2% each year. That's the rate right there. I know this is itty bitty. So let's write this out. So it's going to be y, and we need some initial population. So it said initially it had, the most recent population count had 4,500 people in the city. What will be the population after 8 years? So we're starting at 4,500 people, and we're saying 1 minus, and we're losing 2% each year, so 0.02 times the amount of years you have. So in this case, they want us to do this over 8 years. So I'm just going to go ahead and put an 8 there. So t equals 8. And then whatever this comes out to. So this would give us the amount of people we would have after 8 years with a 2% decrease. So a 2% decay. So let's play this out. It looks like they approximate this really nicely down here, right? This is another way of saying, and I really like to write this part out too. This is another way of saying 1 minus 0.02 is like saying 98% of the population remains. So if you don't like looking at that subtraction, a 2% decrease is the same as saying 98%. And of course, their answer is after 8 years, right? They just put this in a calculator as well. You would have 3,828 people remaining. Cool. There you go. There's the population of this town after 8 years. All right. Nice and easy. Hopefully everyone's enjoying this so far. This is not meant to be too hard. This chapter is particularly straightforward. And that's it. Okay, so let's jump into the homework. I highly encourage you to watch the video here. There's that video. They'll work the problems out just like I did. Come on, internet. Good. Okay, so let's work these out just real fast. So this is homework 10.3, number 1. What is the generic form of the exponential function? Boom, right there. For exponential growth equations, the b value is in the exponential equation must be greater than 1. For exponential decay, it must be less than 1. Okay, that's 1, 2, 3. Number 4 says classify each function below as either an exponential growth or decay. Okay, so for A, I'll just show you visually. Let me make this bigger. So we're just going to say growth or decay for each of these. Let's make that nice and big. Growth or decay. Okay, so for A, this is your A value, that's your B value, right? So this is greater than 1. So this has to be exponential growth. I'll mark that with the block marker. So this is growth. Cool, and the next one, this is again the B value, this is again growth. Okay, again, this is less than 1, so this has to be decay. And this one is less than 1, decay. And this one is greater than 1. Doesn't matter that it's negative out in front. Oh, sorry, this is greater than 1. This is growth. Now, this is the trickiest one. And all this means is that you're starting with a negative population. So you're starting with a negative population, and then you're growing, right, at a huge rate. This is a massive growth rate. So we have growth, growth, decay, decay, growth. Cool. And remember, all I'm looking at is this B value here. Don't be confused by anything. Don't let it trick you. All of our A values are just the starting point. So we can even do that if you want. So starting point here is 5. This one is 1. This one is 1. This one is 7. And this one's negative 2. Okay, hopefully that's pretty straightforward. Number 5. So now it says evaluate the exponential function at x equals 5. Easy enough. So we're just going to plug in 5 here. And let me grab my calculator. All right, this is just a pretty straightforward calculator setup. So I'll just put this right here. Hopefully everyone can see that. So what do we have? We have some negative parentheses, 1 divided by 4, and this is all raised to the 5th power. Okay, there's our first one. Cool. So we know this was decaying. It was starting initially negative, right? And then it was going to decay further negative to that, whatever this is, negative 0.00097. They don't tell you how to approximate this or to round this, so whatever you'd like to put for this. Very small number. So it started at -1 and it got even smaller. Okay, 5b would look like this. So it would be, again, 2 times 1 divided by 3. We have decay again. And this is raised to the 5th power. Okay, there you go. There's the fraction for that value. Here's the actual outcome. Cool. Then finally 5c. We have finally a growth problem. 4 times 6 to the 5th power. So this should be a large number. Yep, there you go. Okay, pretty easy. And again, like I said, calculator related, no problem. You should have a calculator available to you in some form. There we go. Okay, here's number 6. It's our last problem. Okay, a value of a car when it was produced is $28,000. So this is a depreciation problem. You can already see it coming. So the car depreciates at a rate of 13% each year. The equation used to model this is that. They actually just give it to you. Great. They could have made you write this out by yourself, but they didn't. So it means we start at a $28,000 value. We lose 13% every year. How much will the car be worth in 3 years? So all we have to do is plug in a 3 for the t value here. So this is another way of saying t equals 3. And this one, how much will the car be worth after 7? T equals 7. Okay, so I'm just going to set up both of these equations in the calculator, just like you saw before. Let's see. So $28,000 times 0.87. So that's a 13% depreciation rate. And then all of that raised to 3 years. Good. There you go. It looks like the car is going to be worth $18,438 after 3 years. And then see if we can do this again. Yes, check this out. See if I can delete that. And then after 7 years, the car is only going to be worth $10,536. So there you go. Those are the 2 answers. You can write those down, organize your homework. I hope you guys enjoyed this. Remember to take your time on this. Don't rush. And let me know if you have any questions. Talk to you guys soon.